and then come to this. Yesterday we were talking about this, friends. So the topic is about this is something really useful when you are attending some interviews or some certification exams, because people might ask a question on this here. Yeah, sorry. So let's open, create a new program. Just some is versus equal. Maybe this, I'll put it as EQUA. So now let us take a small example. This example gives you very clear understanding about is versus equal operator. Yesterday we did it, but I told that today we'll see that with a better example. This is very simple to understand. There is nothing complex or anything difficult about this. So is the identity operator. You know, right? You take a list like this, something A1 to 3. Okay, we don't know about list, but just observe that. And B equal to, again, one same list. Take one more list. B equal to 1, 2, 3. Same values. Put same values in both lists. Now print ID of A. Okay, and similarly print ID of B. Now the question is, if it is string, if we try to declare same string again, only one copy of that object exists in memory. But this is not string. Strings are immutable, but lists are mutable. So in this case, how many objects are created? Here, two objects are created without any doubt. Let's run this and see here the output. So what happened? Yeah, no problem. We can change this. Okay, I created a different one. I think not as a .py file or what. Okay, no problem. Let me create one more. This is having some issue. Python file is versus equal. Just, yeah, this should be fine. There is, while creating, I think something messed with this. Okay, now run this. Now you see here, I am printing again A, same A for two times. Yeah. So let's run this now. See here now, friends. Now you can see definitely, even though the values are same here, right? So you can see two objects are created, one for A and one for B. This shows that these two are two different objects. Now this is much more easier to understand the comparison of is versus equal. You know what is the purpose of is? Is identity operator, which is used to compare addresses of two values or two objects. Maybe because in Python you can call everything as object. So you can simply say, right? You can, if you want, you can directly compare. What is that? A is B. It returns true if it is if they both are sharing same address. Definitely A is not B. If you look at the address, this is very clear. Both are not sharing same address. Both have two different addresses. If they are immutable objects, they share same address. Just keep this point in mind, friends. Anywhere, if you think that these are sharing same address, then they are immutable objects. Okay, now run this now. See, false, perfect. Suppose equality, definitely content is same here. See, this is having 1, 2, 3. This is having 1, 2, 3. They are identical. Okay, so means what the content of this list objects are same. So if you now check for equality, so how do you check for equality? If you want, you can validate with if as well, but we can directly test like this. A equal to B. What would be the output here? This time definitely it will be true. You can see here. So this is what is versus equal. This gives you a clear understanding here. So what in first case, what A is doing is A is comparing addresses of two objects. Sorry, is comparing address of two objects. This is an identity operator. Equal is comparing content of two objects. See here, as one this list is same, having same content, it is returning true. And they have different addresses, so it is returning false. Is returning false, equal is returning true. This gives you a clear idea about is versus was. So what equal does compares content of two objects. What is does compares addresses of two objects. That is important, friends. So this is the idea. So we are almost done with all this, friends. Okay. So I forget to share this code base with you yesterday. Let me share this with you. If not like this, let me do one thing. Okay. And then this is for string concatenation. I just added this, but don't try to run this. We don't have queries. We don't have any database connectivity as of now. So don't, you can just comment that and test rest of the code. Okay. I'm also sharing all that previous programs we did yesterday. So let me share this as well. Yeah. And also string intro. Yesterday, I think I should have shared, but anyhow, I'm sharing it again now. If you think it's string join, I think we had discussed about joins, I hope, but it's okay. Let me just share all that code base. String methods. Again here. Yeah, I think these are the things which we did discuss yesterday. So string concat, I think we had discussed, even this is shared. So this is, we don't have anything in this. Okay, no problem. Okay, next topic. Let's jump to the next topic, friends. Today we are going to talk about the most important and useful topic in Python. Okay, that is list. What is list here again? Again, we completed string. We are clear with string thing. So apart from string, there is something what we need to understand. Okay. Apart from string, we need to discuss two more small topics. So one is continue and break. You got it right, friends. You have two more things: continue and break. So we'll discuss this along with list topic itself. We don't need to again exclusively spend some time on continue and break. While doing the list examples, we'll cover this continue and break as well. So that you get that idea. I believe I covered continue, but still no problem. We'll just quickly discuss how to apply continue, how to apply break. So the next topic today is about list here. So what is list? List is again a data structure, no doubt about that. That to all this string, this list, this tuple, all these are linear data structures in first place. So one quick thing is your string, whatever we had discussed, or this list, this tuple, all these are linear linear data structures or collections, you can say. Okay. And also these are all built-in data types again in Python. All these are built-in data types. So this is fine. Linear data structure means always linear data structure have indexing. Important point is these data structures have indexing. And indexing thing is same. Whatever we discuss for string, we apply same for list or tuple or any linear data structure for a matter of fact. Okay, friends. So this is quick info. But of course, we know string is what, friends? String is a class. What kind of class is string? It is immutable class. What is immutable? We cannot modify. Cannot modify in sense where at what level? At memory level, not at program level. In program, you can make change. But whenever you make some change, a new object is created in memory. This is what we discussed while discussing string immutability. And we had a very clear discussion with a diagrammatic analysis. If you have any question or doubt on that, just go through that video once, friends. Still, if you have doubts, you can reach out to me or Shiva sir. So this is fine. Then what is list here? The difference is between string and list is a linear data structure. That is both are in that way, both are same. And indexing both as it is linear, definitely these data structures have indexing. Even this is okay. But difference comes here. String is immutable, but list is mutable. So we can modify list. We can modify the content of list. And whenever you try to change this list, no new object is created. The same list gets modified. So that is what mutable is. So list is a mutable data structure. Okay, friends. So, or we can call this as a collection as well. And it is a linear data structure. Linear in sense always something that comes to our mind is it has indexing and it is dynamic. Dynamic means what, friends? It is growable and shrinkable. It automatically grows. Whenever we say something is dynamic, it is growable or shrinkable. What do you mean by growable? Automatically increases size. So when you add elements, it increases. When you remove elements, it decreases. That is what growable or shrinkable is. Okay, friends, and that is what we call dynamic here. See, we'll see all this with examples. Definitely, you get a broad view of everything what we discuss here today. And this is indexed data structure, right? So insertion order is preserved. What is why insertion order is preserved? It means what? In whichever the order you enter a values or add values in the same order, you get the output, or you extract values in the same order. Why? Because it uses indexing. Whatever value you try to add will go and sit in that index. And this index is a linear one. It starts with 0, 1, 2, 3, something like that. Ends with size -1. Of course, we do have negative indexing. You can also use it from -n to -1. And here another important thing, duplicates are allowed. We can have duplicates in string in this, not only, sorry, not string, in list. Of course, in any linear data structure, you can have duplicates. So duplicates are allowed here. And heterogeneous. Heterogeneous means what? This has, we can also we can also insert different types of data into a list. Okay. Maybe if you ask me what is all this, so can you show us with small examples? Yes, definitely. In the next few minutes, we are going to discuss all these characteristics or features of list with practical example. Okay, before I show this scenarios, this characteristics, we go little deeper into this discussion. First, we should understand the very important step here. How to declare a list. we can create list in two ways, either by applying this index operator or by using a list method. This is built in. Or this also access, this list can be used in two ways. It is used to create an empty list, or one is to create an empty list, or it acts as a conversion method. What is that? Conversion method. We know, right? We have data type conversion method. Similarly, this method list can be used in two ways. One is for creating an empty list, or it is also used as a conversion method, means converting string to list, tuple to list, some dictionary to list, set to list. So likewise, we can use it as a conversion method. So that is the idea, friends. So we can create list in two ways. Just apply this square brackets, this index directly. Like this creates a list, or you can apply list method. It's up to you which one you want to use, is your choice. So this is the quick syntax. This is how you can create a list like this with this one, with this index operator, or with the square brackets. And in that you can just pass your values like this. Okay, some value 1, value 2, something like this. Okay, this is the example. This is the syntax, friends. It's so simple. This is the example of a list here. You can see some fruit list equals something like this. Or something like list 1 equal to something like this. Some list 2 equal to something like this. You can see. This is actually a list of strings. You can see, or list of fruits. This is an integer list. This is a string list. This is a heterogeneous list. You can see it has integers, string, and boolean. Okay, friends. So now, and this is another way of creating list, something like empty. Let's just quickly test these things. Okay. Instead of just quickly checking on this. So what we do, right click and then new, and then Python package, just create it as a list handling. And then right click new and then Python file. So list intro. So now what are the two ways we can create list with something like some list one. Sorry. Introduction to list. Or you can just say two ways of creating list. So the first one is some list one. Don't again use list directly because list is built in. Some time back, I used some built-in class string. I ran into some issue. So make small changes to that existing one. Okay, list equal. This is an empty list. So suppose you print it. Still it is a valid one, but empty. We have to add values to that later, sometimes in some cases. Okay, so now if you print it, you get same empty thing. And if you want to see if it is really a list or not, then just quickly check type of list. So to create list, just we apply this index operator. Okay, this is fine. Next after that, what is that? Another way of creating list is you can see this. Okay, what is it? You can also apply list method. Even that creates empty list. So you can just say list 2. Okay, and you can also say list 2 and then type of list 2. Okay, right click run this and you can see here. What is this? In both cases, we have created a empty list class. Is this clear, friends? So that is the idea. Now, let us start playing with values. Suppose I created a list like this. Now, adding values to a list. How do we add values to a list? We can create it in different ways. So one is, so we can do like this. You created an empty list. You want to add values. How do you add? Simply something like list one equal to, you can add values directly. You can create a list with values while while declaring list itself. This is one thing. There is another way. We can also dynamically add values. This is just adding populating values at the time of creating list. Okay, this is we do this while learning here in these kind of learning sessions we do this. But in real time, what do we do? We dynamically populate data. What do we do? We dynamically assign data. Maybe that can be done in two ways, either reading data from files and data from files. One scenario from a file and we filter and we copy data to list. This is one scenario. Another scenario, reading data from a table, from a database and copy data into a list. So these are different scenarios. Okay, friends, to dynamically populate data. But here, okay, you got it right, friends. So one scenario is this one, second scenario is this one, likewise. Okay. So, but anyhow, we go one by one. I don't want to confuse you. So what do we do? This is how we add values to a list, friends. Okay. So this is one scenario. Again, even I will show these things once I discuss the concept of, I mean, all the APIs, methods of list class. Once I show all that, then I will show how to populate data dynamically into a list. We will see all those scenarios. Okay, this is a simple example how to start with list. So we just created an empty list, sorry, a list here with some values. So let's print it. So these things I'll cover, just giving you an idea, right? So let's print list 3. Okay, list 3. Now right click and then run this. You can see here all list of values. So we can create different lists. It's up to us. So a fruit list or an integer list or a heterogeneous list. You can test all this if you want. Let me just show you. So if you want, you can print fruit list. So here, okay, you can just directly say something fruit list. Similarly, you can apply list 1, list 2. Maybe you can put this, it's up to you. List 4, list 5. Okay, you can just pass it here. Okay, passing them here. Okay, now you can see the output here. This is fruit list here. If you want, you can print that list details as well. Suppose from which list you are getting details. You add a description in this F string here. Okay, so that is the idea, friends. You got it right. This is just an introduction. There is so much to discuss in lists. Got it now. Next important thing we need to discuss is indexing of a list. Another important thing. So list indexing. Okay. But before that, we'll do one thing. Let's first test features of list. Okay. Features of a list here. So first thing, this is what heterogeneous. Heterogeneous means here itself we can see we can pass different types of data to a list. Of course, it's not mandatory, it's up to you. But it is heterogeneous in nature. We can have integer or string or boolean or mix of data. Different types of data. That is heterogeneous. But maybe if you ask me, can I put all integers? Yes, it's up to you. When you have float here, see. It doesn't mean that it should be heterogeneous always. Right, you can copy all int data, all float data, all string data, anything is fine, it works. But an FYI, for your information, this is heterogeneous. One character is clear. We have added heterogeneous data, we printed, and we found that it is working fine. Next, we do one thing, right? Add same data again. I duplicate data. Sorry, friends. Copy this. Then what? Again, paste it. See, we have a duplicate data, right? Now print again this one. Some list 6. We are adding a duplicate data. Sorry, print it. Simply copy this print and put here. Now, when I print it, it allows duplicates. It allows duplicates. Right click and run this. You can see here. And also another important thing. Insertion order is preserved here. If you see here, in whichever the order you are passing values, in the same order you are getting the output. See, you don't see any difference in the order of passing values. So this is insertion order is preserving, what we call. So about dynamic nature, adding and removing. Soon we will talk about it. We apply some methods, delete methods or insert methods or otherwise append methods. When you use all that, you can dynamically add data or dynamically delete data. That gives you an idea. List is dynamic. You got it right. So that is the idea, friends. So what do you do right now? Any dynamic data structure is growable and shrinkable. In a list, you can add 100,000, 1 lakh, 1 crore, or for a matter of fact, any number of objects. There is no limit for adding objects in Python into a list. Okay, friends. So, and this is mutable object. When you are adding so many objects, always this is a good data structure for performance. So this covers almost all features. What is that? We had discussed that few things. So what is it? List is indexing thing. We'll see that now. So insertion order is preserved. Duplicates thing we see. Heterogeneous thing we have observed. Dynamic nature we can just check on that when we get started with API of list. Okay, when we start discussing list API, then you can understand why list is dynamic, friends. You are going to get some clear picture about that. Okay, it's very beautiful. These topics are really beautiful. Next important thing you need to learn in Python is indexing, because this is a linear data structure, right? So as it is linear data structure, definitely they have indexing. So non-linear means that set and dictionary, all these are non-linear. And this string or this list or tuple or all these are linear data structures. They definitely have indexing. We did discuss that. Now let's take a small example. Same example. How does this indexing would be? It would be simple, right? Something like some list 7. Okay. So now, what do you do right now? You apply indexing. How do you do? This is 0, this is 1, this is 2, 1, 2, 3, 4. Okay, this is indexing. We already know this. Indexing of a list. Right. Also, this have negative indexing. What would be that? If there are 5 values, it starts with -n to -5. -5. Okay. And again -4, -3, -2 till it goes -1, -3, -4, minus. Sorry, there is -4, -3, -2, -1. Okay, so this is negative indexing. You can see it now. Got it, friends? So this is how indexing is available for this list data structure. Not only list, in the concept of indexing is almost similar for these data structures, some string or list or tuple, and any linear data structure. In fact, if you just ask me, if you want to make it generic. So this is idea, friends. This is idea about what is it? This indexing thing. Now, how to extract values from a list? This is the syntax. Okay, to read value from a list. Okay, we can apply slicing, definitely, yeah. So on any indexed data structure, we can always apply slicing. This is fine. Now, now what do? We do one thing. Extracting elements from a list. How do you extract syntax or reading values from a list? There are different ways of doing. I'll show one by one. So first thing, approach one. Maybe one approach is okay. Approach one, accessing each value through index, list index, using list index. Okay, that is one thing. The syntax look like this, something like that list name. So that I am naming it as variable name of. So that index. This is simply, this is how you can extract a value from a list. That list name and then index of that value. So here, if you see here, so suppose let's see this now. So list 7 of 0. Print it. Of course, directly print it for now. So this, what this does, this try to extract value from 0th index. Okay. Similarly, so what do you do right now? You can print, you can have few more print statements. Okay. If you want, you can add more. That's up to you. Just for testing, 3 are enough, friends. 2 or 3 should be fine. Suppose this extracts value from 0th index, this one. So 0, 1, 2, all this. Right click and run this. 1, 2, 3. You got it right, friends. So this is idea about indexing of data structure. So this is how to extract each value from a list. But in real time, do you think we follow this? This is something we do very rarely. Directly accessing value through index. This operation, doing it one by one, is almost, I say that we don't do this. So whenever we do any operation on list, we always use iterators. You got it right, friends. Of course, this is approach one. Okay. This is something very basic thing, friends. And we generally apply this while, where we apply this while trying to do some quick testing. That's all. Otherwise, we don't generally use this in real programming. Okay, next one, approach two. Iterating list. This is something we always do when we are working in a development. So iterating list. For that, we use for some val inside some list 7 colon print of val here. So this is what we always do while working with collections. We always apply this for here. Without for, you cannot imagine most of your development, especially in Python. Right? See what happens now. Every time loop iterates, one value is copied from the list to this. dummy variable, and then you do some processing here. You got it right, friends. So this is what we do. So now if you run this, you get you iterate value by value until all elements from the list is iterated. This is something, the approach we use in real time while in development. So right click run this and you can see it is iterating. You can see first last 5 values. It is printing value by value here. So this is one scenario.
But here,
Similarly,
if
what?
you need only specific value means we can mention in the list,
So,
right?
sorry, can you please repeat it, ma'am?
Sorry, if you want only a specific uh, value, like for example, we have 1, 2, 3, 4, 5, right? So
Yeah,
now if we have,
yes, ma'am. So if you want to access specific value, then you can apply index, right?
yeah, I don't like instead of index in the second approach, we cannot do that because, yeah, in first approach, yes, we can do that. In second approach, we'll only get whole the values, not any specific values.
Correct, ma'am. But most of the time we follow this approach in real time, not this one. Because
Okay.
this kind of specific thing is something rare we do. I don't say
Mm,
that,
mm,
I don't deny completely, but this is something we generally don't need this. Because most of the time you need to fetch data, iterate it, and we do on bulk data, not on just something on a specific item. But of course, we are discussing all approaches, no doubt. So if you want to extract something specific, this indexing thing is there. Choose that specific index and try to get it. That's it. So, but what I am trying to tell here is in real time, most of the time, right? I think I mentioned that point as well. So here we do for quick testing, you can do all this, but the actual thing in real time is most of the time using iterators is something really important. So, and we always try to do this approach. That's all. That's what I'm giving you. So what kind of approach we generally keep using in development is something I am highlighting. But something specific, yeah, definitely you can do this. I think it's clear, right, madam?
yes, sir. Yes, yes. Understood. I
Yeah.
thought any possibility that we can even do for second approach also for individual value. So that I now got to.
No, no. This is generally for iterating on a
Understood.
bulk data, right? When you have
Understood.
huge
Yeah.
data to iterate, and this is something we generally keep doing in development, ma'am. So
Okay. Yes.
this something, a specific value is a rare scenario in that if you want to extract something specific, yeah, you can use indexing. This is okay. But what I'm trying to highlight again is most of the time in real time without loops, it will be very difficult to process that huge data. So that is the idea. So this iterating is something we need to use again and again, and we have to again master this approach. This is important. I hope that is clear because I do keep working on uh, generating reports every day. So I keep implementing lots of this Python data structure. So that's why I am trying to give you a clear insight, like which is important to follow. And also, of course, we are discussing how to extract some specific value from this list, either by using positive index or negative index. Yeah. So, and someone is again asking question. Please, what's your question?
Yeah, Manoj,
Yes,
from
please.
this is Narendra.
Yes,
Uh,
yes.
See, for when we do indexing,
Yeah.
print list 7 0 colon 3, it will display the 0 index to 1 2 3. It will display. Or suppose if you key 0 to 3, so I want to perform specific, like I want to display starting one and ending one only. I don't want middle digits or middle values. Zero index I want, and final index -1 or whatever would it present
Correct.
in our so
Correct.
I want to pick and I want to apply some different value. When we have starting index, I want to display something. When we have ending index, I want to
See,
display something.
yeah. So this is something, this is a very straightforward scenario, Narendra. One thing, see, when you are applying slicing, when you want to, let me give you a clear idea. When should we apply slicing? If you want to get a part of that data structure, it might be string or it might be list or it might be tuple or whatever it is, then we apply slicing. And slicing is something where we follow a linear order. We have to start somewhere and somewhere, and we cannot have a this thing. Random indexing is not possible with slicing. Is that clear, Narendra? First point. So,
Okay,
so
random index is not possible here.
yeah, not possible because the slicing is something where we need to provide start and end, and we cannot have something random there. So it won't work even if you try that approach. Is that clear?
Yeah, yeah.
So now second thing, coming to your question about getting a start value, that is one thing, getting end value. So it is something, see, generally we keep doing this number of times. So suppose I have a string, I told you, right, Narendra? So if you want start and end, this is very simple. Start means you can directly choose start index, that zero, you know very well. And end index,
Yeah.
you can, easiest thing is
-1.
to get end. Suppose somebody is saying to get end, don't try to get length and again find -1. You don't need to do all that in Python, not needed. What you can do simply, you can say a list of something zero. This gives you start value. So this is straightforward. Suppose you want end value. Generally, if you don't have negative indexing, then definitely we have to find length and then we have to say something length of -1, all that. But here we have negative indexing, simply apply -1. So this automatically gives you what the start value and end value. So what happened?
No, you used
Yeah,
list variable.
yes,
You have to use.
no, no problem. Why this is happening? Because I have iterated this list. This is good to know actually.
No,
List
no,
of,
no. That is not for iterating. You mentioned
okay,
list.
okay,
You
okay. I
have to
got it. I
mention
got
list
it.
one or list.
Okay, I got it. I think I am using built-in list class. Yeah, sorry. So now you see here. So this is what you should apply, Narendra.
Yeah,
Rightly.
I get it. I tried this, but I have a doubt. Like even I checked, there is no solution when you want to pick specific values like 0 or 3. It won't accept. It will always give 0 hyphen semicolon 2. If you mention, it will give 3 or 2 values, whatever you are mentioning inside the index. We can't particularly select like 2 values, start value and end value in one script.
Yeah, sorry, friends. I think I just had a power breakdown. Can you hear me now? Sorry. Am I audible?
Yes, Manoram.
Yes.
Yeah, let me share my screen. There was a slight power breakdown. Just coming back to this. Narendra, I think we are here, right? We are talking about. Yeah. Uh, can you hear me?
Yes, Manoram.
Yeah. This is something. Yeah, you can see this gives you a start and end directly. This is something we apply even while working in some kind of scenario or something. Narendra, is that clear?
Yes, yes, Manoram. You can go ahead.
Yeah. So this is slicing generally is applied to get some substring. Okay, that too, some part of a string. Usually it has to be we should have a proper start and proper end index. That is important. Okay, we will anyhow talk about slicing. Okay. Next after that. So we had covered these important things about indexing, how it will be, and you can apply negative indexing as well. Just a quick check for you. So what you can do is you can add, suppose you start with -1, -2, -3, something like this. -2, -3, something like this. Then run this now. And you can get here. So maybe we can add a print here just to make sure that print extracting each value from a list. So second scenario, we are iterating list. Iterating each value from a list so that we have that clear description there. Okay, let's run this now. Now you can see here, this is iterating, this is extracting from a list. You can see here 1, 2, 3, last three values from the list, and probably first three values from the list here. You can see here. So, and last three values. Okay. So last three instance, -1, -2, -3, 5, 4, 3. You can see here 5, 4, 3. So that is the idea, friends. So now we have to talk about important thing, that is slicing. Slicing we had discussed, even we have a lot detailed discussion about slicing when we discuss strings. We can apply same with list as well. Suppose you see here you have list of values. Maybe you can create a new list if you want. So what is that? Some list equal to some list items, something equal to, you can just take some 1, 2, 3, 4, 5, 6, 7. You can add how many ever you want, friends. I'm taking 10 up to 10. So slicing already is clear for us. Maybe if you want, you can also add some. We'll talk about that again in one more scenario. You know the syntax of slicing, right, friends? What is syntax? We have that var name, whatever data structure name is that in brackets, start index, we know this, colon, end index, we know this, and then colon. We can provide step. This is optional. Step is optional, friends. If you wish, you apply this. If you don't, you can exclude it. It's up to you. Generally, step is required if you want to do some incrementations. But if you want to, by default, extract value from start index and end index, we don't need step. But that too, incrementing each value by whatever that is specified here in the index. Suppose if you want to increment index by 2, by 3, by 4, then we have to apply step. That is one thing. Second thing, even if you want to get elements in reverse order, right? Then even in that case, we have to apply step. But in regular scenarios, step is not needed, right? When you try to fetch data, suppose I want to just fetch first three elements or last three elements or middle some x elements. Okay, we can just use start and end index. That should be fine. Okay, fine. Let's do some scenarios. Let's apply some use cases that gives you a detailed this thing. Suppose how can we apply slicing here? Suppose I want to get first three numbers. You know how to do this now. Simply what you can do, you can apply a slicing, print some, otherwise some list items. 2 equal to, this is again a substring here, okay? List items 2 equal to, sorry friends. You can do one thing here. You can apply a slicing. I want to get first three elements. So then what is that I should do? List items of 0, otherwise I can even exclude 0, 0 colon 4. So 0 colon 3, sorry friends, because here it uses indexing, right? So it starts with 0 till it goes up to 2, and this end index is exclusive. This is discussed number of times. So now this we can print that substring, I mean sublist, sorry. This filtered list, you can print it if you want and see the output, see here. So you got 1, 2, 3. So we try to have a sublist from the existing list. Similarly, I want last this thing. Then simple thing is applying last three values. So how you can get last three? There are different ways, right? Some again you can copy this one, paste here. Last three values means suppose the easiest thing is -1 to -3 colon, because this is something 10. If you want to go from right to left, always you have to apply some step here, negative step. Left to right means we'll see that now. If it is left to right, how it goes. If it is right to left, how it goes, we'll see. But this is going right to left. See here. So -1 colon -3 colon, you have to pass a negative step. This is important, and change this variable name here. And then just what you have to do. Yeah, see this. Then right click and then run this. So you can see here 10, 8, of course, do one thing. Take one more, -1 to -4. So it comes up to -3. Okay, now run this now. You can see here. We got last three values, but in reverse order. Suppose I want it in the normal 7 to 8. Right? I want to start with 7, ends with 10. Then what I can do now? Simply, but I don't know the index of 7. Okay. So suppose we have large data, in that I need to start somewhere and somewhere. How to dynamically get the index of 7? So one approach is last three values means if you know the size of list, that is easy. So if size of list is 10, we know we have 10 values inside this. So this size or length of this is 10, no doubt. Then as per the indexing, we can get last three values. So getting last three values, easiest thing is if you already know this size, easiest thing with negative, let's apply this and see. So we start with -3 and end with -1 and see if this is going to work for us. So list 4, list items 4, and then you can print this. There are different ways. We can apply positive indexing as well, like 0 to n, all that. I'm just showing you how you can play around data, right? Even with negative indexes, right? So -3 to -1 means this one. So we know, right? This is -1, -2, -3, -4. This goes till -10 at the rightmost side. So last three values is, this is so simple to get that. When you have that negative indexing in mind, let's try this. So list item 4, I should print here. Right click and run this. You can see here 7, 8, of course. And then maybe you do one thing. remove this. This gives you the, again, the last three elements of this sub list. Okay, this list. Right click and then run this. Perfect. You got 7 to 10. You got it right, friends. This is the idea. Understood now? This is how you can play around this slicing here. You're applying negative indexing. Suppose I want to start with 6 and end get up to 10. Again, this negative indexing is so easy for you. When you know the length of that, based on length, you can decide what would be the position of that, and then you can extract. Okay, suppose applying positive indexing with negative index, you know how it works. So list item 5. Okay, and then you can start with the, if you apply last three, last 4, I want to extract as a slice. So index of 6 is -5. So sorry, 5. 5 colon. Just you can ignore the rest of the, that end index is not needed. It's optional. Then if you are trying to extract last part of a list, second part of list otherwise. If you want, you can also put here some 10 or some 11 actually. You have to pass 11 so that it iterates till 10, 5 to 10. Okay, but it's not needed. We already discussed this. This is optional. Now you can just pass some 6 and then you can print it 6 here. Okay, and then run it now. You should get elements from, so from fifth index instance 6 to 10, you got it. This is what the expectation, right? So this is how you can play around slicing, friends. Okay, suppose I want middle part, I want 3 to 7. It's important is, only thing to keep in mind is that what is the start of that particular thing and what is the end of that particular element. That is important. Now I am giving you this requirement. This is very important. This helps sometimes. So, I want to extract from 3 to 7. I'm not even showing you the list. Now you get it. Now I can count this. What is the index of 3? What is the index of 7? And then I am able to pass start index from 3 to end index of 7 or plus 1 of that index. Because we have limited values, so that I can calculate easily or count it easily and then pass start and end index. Suppose if there are 100 elements, 1,000 elements, in that case, how do you it's difficult, right, to get that. Of course, we don't have a problem even in that. But just to quickly cover a scenario where we can dynamically get index and apply slicing dynamically, just where you don't know what is the position of 3 or what is the position of 7, still I need to make it. Right, how do you do? In that case, we can apply directly. We know the value is 3 and 7. So index 1 equal to, what is that? So that list items of dot, we can say dot find of 3. Okay, this gives you index of 3 and index 2. So what you can do, index 2 equal to find of 7. Okay, and then print. Just for quick testing, we are printing it. So index 1, index 2. These are all useful for you, friend, because I'm sharing something which I do in my day-to-day development, so that it helps you. That's all. Okay, right click and run this. So has no attribute find. Okay. Then do one thing. If you don't have find, then we have index. Directly pass 3. Index method is there, right? Dot index, just pass 7. So this gives you index of 3 and 7. No problem. We can come up with, we'll talk about API after this, maybe in tomorrow's session, all methods of list class, so that you understand which methods to apply, which we don't. Easiest thing is simple. When you say dot, you can check for list of methods available and choose what to apply there or which one to apply. Right click, run this now. and you have 2 and 6 as indexes. So you can start creating slicing now. So we got that, right? You can dynamically choose, paste it here. Now you are extracting that, and here dynamically directly pass ind1, index 1. And if you want, you can choose index 2 plus 1. Why? Because if you pass just index of 7, you get till just what, and sorry, this one. If you pass 6, you get till fifth index. So plus 1 you should add. If you pass 7, then this internally interpreter iterates till 6. I want elements from what? From this is my requirement, right? I should start with 3 and with 7. Means all this sublist I need to extract. Then we should always just add plus 1 to the end index so that we get till that index. Okay. So now you can do one thing. You can just change the name of that and then print it. Now run this. Now you can see 3 to 4, you are able to get it. Of course, we can look at that index and just pass it, but this is something useful scenario for you friends. There are certain cases where I implemented this to get a index dynamically, and then without, I don't know where that value sits. In such case, I used to implement these kind of scenarios. So this is something useful for you friends. Okay, let me share this with you. Okay, let me share this. Tomorrow, what we do is, I think you are good with slicing, right, friends? Is that clear for you? Or if you want to cover more scenarios, I'll add more to tomorrow's session, or else we'll jump to the next topic of what is it? Methods of this list class. And after that, again, we play around data like dynamic adding, dynamic deletion, and some, at least we do some 10 to 15 projects on covering different scenarios. Then we go to the list comprehension again, something really important, right? So likewise, we just keep adding scenario by scenario. That's it for today, friends. Any more questions? Please let me know. Sorry for this sudden power hiccup. All of you are good with all this. Any questions? You can always ping me back again after this session or anytime. Clear? Okay, then shall we stop here, friends? Any questions? No, right? So, okay, then. Thank you. We'll catch back again tomorrow with the methods of list class tomorrow.